this video, we're going to focus on thermal stress and strain. So let's start with the first problem. A steel circular rod with a radius of 10 centimeters is placed between two vertical supports at 15 degrees Celsius. What compressive force is exerted by the vertical supports if the temperature increases to 40 Celsius? So let's say that's the first vertical support, and this is a steel beam placed right between them, and here's the next vertical support. So the vertical supports are fixed in place. Now what's going to happen to the steel beam if the temperature increases? If the temperature goes up, the rod is going to expand, so it's going to get longer. Now, because it's fixed in place by these two vertical supports, those vertical supports will exert a force that will prevent the rod from expanding. So therefore, the vertical supports are under thermal stress. Keep in mind, stress is the force applied divided by the area. But in this example, we want to calculate the compressive force that is exerted by these vertical supports. So what equations can we use? Well, we know that the elastic modulus, also known as Young modulus, is the ratio between stress and strain. And stress is defined as force divided by area. Strain is the change in length divided by L0. So in this equation, let's isolate F. So first we need to rearrange this fraction. So right now we have that E is equal to F divided by A, and that's divided by the change in length over L0. Now in algebra, perhaps you heard of the expression keep, change, flip. I'm going to keep the first fraction the same, change division to multiplication, and then flip the second fraction. So now let's multiply both sides by A times delta L. So on the right side, these will cancel. On the left side, we're going to have E times A times delta L, and that's equal to F times L0. Now, another equation that you need to be familiar with is this one. The change in length is equal to alpha, the coefficient of linear expansion, times L initial times delta T. So anytime you increase the temperature, you can calculate the change in length based on that formula. Now what I'm going to do is replace delta L with this expression. So this is going to be E times A times alpha L0 delta T, and that's equal to F times L0, or L initial. Now we could cancel the initial length of the rod. So now we have the equation to calculate the compressive force. So the compressive force is going to be the elastic modulus, or Young's modulus. These are the same. So you might see this symbol in the equation. So it's E times A times alpha times the change in temperature. The elastic modulus of steel is given to us. That's 200 times 10 to the 9, and it's newtons per square meter. Now to calculate the area, we have a circular rod, so the area is going to be pi r squared. So that's pi, and 10 centimeters is 0.10 meters if you divide it by 100. So 0.1 squared times pi will give us an area of 0.03416 square meters. And then alpha, the coefficient of linear expansion, is 12 times 10 to the minus 6 times 1 over Celsius, or Celsius to minus 1. And then the change in temperature, which is the difference between the final temperature and the initial temperature, So that's 40 minus 15. So that's a change of positive 25 degrees Celsius. So notice that the units square meters cancel and also Celsius cancels. So we're going to get the force in newtons. So it's going to be 200 times 10 to the 9 times 0.031416 times 12 times 10 to the minus 6 and then times 25. So the answer is going to be 1.88 times 10 to the 6 newtons.